Okay, so the last couple of days of this last unit are revolved around derivatives and integrals of inverse trigonometric functions. A little bit of this is going to be review, but we got to go through it quickly. If you're struggling, watch the video later, but it's just review of pre-calc. Okay? The big things of pre-calc that you need to know are the following pieces right here. Okay? So, if I'm looking at arc cosine, otherwise arc cosine, which is right here and here, or if I'm looking at arc sine, which is right here and here, and last but not least arctangent, which is here and here. I'm looking at the ranges for you to know so that if you go to your calculator and you were to do this, if you put arc sine of -1/2, it would spit out an angle. Okay? And if you have a calculator right now handy in degree mode, go for it. Okay? But what this is asking is, what angle would yield a y value that has a -1/2? Okay? So unit circle, if you were to quickly go to this, you know the y value is because it's sine, and it's a -1/2. So we go 3, 2, 1. And we go back up. 3, 2, 1. What we want is this -1/2 right here to match the y value that they're saying I should have. How many answers should I have to this in a complete unit circle? 2. I should have one right here, and this is review, and I should have one right here. So at 7 pi over 6 and 11 pi over 6, those would be my thetas. Now, those of you, some of you have put this in your calculator already. If you put this in your calculator right now, it doesn't spit out both of those angles. It only spits out one. So if you did the arc sine of -1/2, which one does it spit out? It spits this one out. Okay? It spits the 11 pi over 6, but it doesn't give it to you as 11 pi over 6. Because of the restricted range of arc sine, which is basically from -pi over 2 to pi over 2, like a number line. What's the coterminal angle for this that would fit in this range between -pi over 2 and pi over 2? -pi over 6. So -pi over 6 would be somewhere about right here. So that's what this answer would be, because we are in radian mode. We're in radian mode in calculus all the time. So why did I not, and you could put not 11 pi over 6, because of the fact of we wanted in that visual range of arc sine. Go with me? Now, real quick, can you go back to my desk real quick? I'm going to show you what the sine function looks like real quick. And I'm going to do the arc sine, and I'm going to show you why it has these domain restrictions. Because these are domain restrictions that you'll have to memorize. And the way that I memorize them is that I just look at a circle, and I know that arc cosine will have a range from 0 to pi. Because cosine is an even function. And arc sine and arctangent are odd. They're going to have between -pi over 2 to pi over 2. So 0 to pi for cosine, -pi over 2 to pi over 2 for sine. And the reason why it's this and this is because of what I'm about to show you right here with Desmos. So go ahead, if you can, please, put in the sine of x. Okay, so there's your sine of x. Here's your sine graph, okay? Now, we're going to do arc sine of x. So on the next one, I want you to put just A or C, arc sine of x. And there you have this graph. A reminder, and this is review from pre-cal. If I want to reflect the red graph across y is equal to x, because that's what you do when you're looking at inverses, like x squared and square root of x, inverse functions, they fold over that. Notice that this inverse is a function when the original passes what line test? Let me say this again. Arc sine, which is the inverse of sine, passes the vertical line test, where the original, which was sine, passes the what? The horizontal line test. So looking at this, I know that the horizontal line test is from negative pi over 2 to pi over 2. Okay? So you with me? So if I'm looking at sine, the domain that I'm looking at is from negative pi over 2 to pi over 2. That's where it passes the horizontal line test. The range is what? What's the range right there? It's not a difficult question. What's the range? Negative 1 to 1. But then, if I'm looking at the inverse, what's the domain? Negative 1 to 1. What would the range of the inverse be? Negative pi over 2 to pi over 2. And this right here is what we're doing when we look at this. We're saying that from negative pi over 2 to pi over 2, that's what we're talking about. That's the range of arc sine. How's that for a review? Okay? So arc sine, arc cosine, and arctangent, we're going to be looking at that. Can someone tell me why arc secant is not at pi over 2? Well, think about it. Arc secant is the reciprocal, or it's dealing with cosine, right? And what's the cosine at pi over 2? 0. And if you flip it, it's undefined. Okay, that's the same thing over here. What's the sine? What's the sine at 0? 0. But if you flip it to make it cosecant, it's another undefined. You with me? Okay, so there's a little bit of recall, not too much memorization, because you kind of should know it by now. All right, you're good, Tyler. All right, arc cosine. Again, there were two answers to this. Again, there were 7 pi over 6, 11 pi over 6, if and only if you saw something that looked like this. You list them both out. If you don't see this, this one was the only one that worked, but you wouldn't write it as 11 pi over 6. You would write it like this because of the range of arc sine. Okay, so let's move on. Cosine. Okay, so there's no interval. I'm not saying from 0, I'm just saying just like you see it there. So you should only give one answer. The way I would want you to think about it is, first of all, cosine is what kind of value? X. So we want negative x's. So negative x's are in quadrants 2 and 3. What's the range of arc cosine? 0 to pi. 0 to pi. So the overlapping spot is right here. This is where we want to find the x value that is a negative root 2 over 2. We know that's going to exist here at the 45s because it's negative root 2 over 2, positive root 2 over 2. Unit circle has to come back, okay? Because we're looking at this whole thing, xy is right there. Can someone tell me what the answer is? What's this angle? 3 pi over 4. Is 3 pi over 4 in the allowable 0 to pi range of arc cosine? Yeah. So we would just write that. Pretty straightforward, guys. All right, new stuff. Ish. If I asked you to find the sine of the arc cosine of 4/5, it's the same as if I were to ask you that. Okay, here we go. What do y'all do? Let's see what, because you've worked with this before. How would y'all start this?
First, find the arc cosine.
So let's find the arc cosine of 4/5 without a calculator. How do you find the arc cosine without a calculator? You draw a triangle. You draw a triangle. And I didn't realize this, so college, and it's so much easier when you just draw a triangle, okay? So if I draw a reference triangle, I always want you to start like this. That's an easy way to start it. It's going to be a right triangle because it's trigonometric. SOHCAHTOA. Right triangles. Now, cosine, SOHCAHTOA. Cosine is dealing with adjacent over hypotenuse. Okay? Which one of these is my adjacent that they gave me? 4. And the hypotenuse is 5. So if adjacent is 4 and the hypotenuse is at 5, what would this missing one be? 3. 3, 4, 5, right triangle. You have to solve the triangle so that you can then say, what is the sine here? The sine would be opposite over hypotenuse, which is 3/5. Go with me? Now this is basic, but a lot of people overlook it. What kind of value does the thing that I highlighted, what kind of value does it represent? The radian measure, the theta. So this right here, this is going to help you with what we're doing today with derivatives and stuff. All that is just theta. All that is the angle, as if you were to put your body right there where the angle is at, and look around and say, this is adjacent, or this is opposite, this is the hypotenuse, from your reference. Any questions from that? Okay, so let's do the next one. The next one is going to be the arc cosine of x. So I'm going to build my reference triangle. And from, remember, this right here is theta. All of this inside the parentheses is theta. And cosine is adjacent over hypotenuse. So what's my adjacent? X. What's my hypotenuse? 1. There's an understood 1 that goes right there. Okay? What's the next step? Solve the right triangle. So what is going to be my missing side here just by using Pythagorean theorem? Yep, square root of 1 minus x squared. It's not a squared plus b squared equals c squared. It's starting from the c and working backwards. Okay? Now, what is the sine from here if you were to put your body right there? Yep, opposite over hypotenuse, because that's SOHCAHTOA. So it'd be the root of 1 minus x squared over 1, done. Okay? And then we'll do one more. The arctangent, reference triangle. Tangent is opposite over adjacent, TOA, if you will. So it's going to be opposite over adjacent, and if I build my triangle, careful, what should I write as my final simplified answer for my hypotenuse? No, not 3x squared.
3x squared plus 1.
No. Simplified.
9x squared plus 1.
There you go. The 9. So it's going to be a squared plus b squared, and then take the square root, right? But simplified, what you're going to see it as is that. Okay? So if I said, what is the secant from this angle, you're just going to say it's the flip of the cosine. So instead of adjacent over hypotenuse, it's going to be the hypotenuse over the adjacent, which would be that. Don't let pre-calc mess you up of finding these calc problems with that simplification.
If it was the cosine, would we have to rationalize the denominator? Or we just leave it as square root?
So here's what I'll say. In the past years, I always would take points off if people would put negative powers in answers, and always take points off if they left a denominator with a square root. The square roots are allowed, and the negatives are allowed. But the big reason of it is in the answers on the AP exam, you don't see it that way. You see it mostly where they're positives. Why? For 2 reasons. One, it's just kosher the way we've learned it to be. But the other that I truly 100% agree with is it promoted so much more algebraic manipulation and practice on your end to know how to work with those numbers and variables and all that. So it's practice. So if you leave it as a negative, I think there's so many more mistakes that can happen with negative powers, I'm going to still count it wrong. But if you leave it with the square root in the denominator, it's fine. Do you understand my logic on that? Okay. I just want to eliminate simple errors, especially with negatives. All right. So now we're going to take the derivative of arc, the arc functions. Okay? This is going to feel weird at first. What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. So now what we're doing is we're going to take what is the derivative of the inverse trigonometric function, which is kind of weird. Like, what's going on? You with me? This is not to be confused. Please do not confuse arc sine to be the reciprocal. Please don't do that. Because what is this really? Cosecant. And cosecant is still a side ratio. This is not a side ratio. It's going back from side ratios to what? The angle it came from. So these are side ratios, whereas this is the angle that it came from. Otherwise, these are like the root 2 over 2's, and these are like the pi over 4's, and so on and so forth. You with me? Okay. So, let's come up with the rule. You know all kinds of rules. You know product, quotient, chain rule, all these rules, right? We're going to come up with the rule for arc sine. My goal is to find dy dx. What do you think I should do first? Because you don't know. If I were to derive both sides right now, you don't know the rule right now of what would this be. So we're going to find a way to discover it. What do you suggest we do? Not 1 over cosine, but that's a good. No, that's a good thought. What makes this difficult right now is this. So what if we took the sine of both sides? If I take the sine of both sides, I have sine of y is equal to, whoops, x. Do you see how the sine and the arc sine cancel? Okay, here we go. My goal is to find this. So what could I do right now? I could derive it implicitly. What's the derivative of the left side? Cosine of y times dy dx. There we go. This is what I needed. And now I have it. What's the derivative of the right? 1. Because we're in respect by default to x. Okay? Alright, here we go. So, again, you can't solve this per se without drawing this reference triangle and knowing that sine, arc sine of x is like x over 1, says the opposite is x, the hypotenuse is 1, so that my missing side is square root of c squared minus b squared. And from here, I'm going to take what is the cosine of y. Can someone show me where y is on the chart, on the graph? Where's y? Theta, nice. Y is the angle. You with me? So y is theta. So yeah, you can write down y if you want. And if I took the cosine from y, well, it would be adjacent over hypotenuse. And the answer that you should get is the derivative rule is, oops, let me not simplify it quite yet. It'll be adjacent over hypotenuse is this times dy dx is equal to 1. Therefore, the derivative rule for arc sine is 1 over the square root of 1 minus x squared. Okay? Now here we go. I want you to think of this as chain rule. This x is stuff. Okay? That means x could be x by itself. X could be 2x squared. X could be 4x, whatever it is. That means the rule, the blanket rule for this right here in respect to u is going to be 1 over the square root of 1 minus u squared times the derivative of that cream. That's the rule. Can someone tell me from what I just showed you, what does u represent? U represents the function that is a composite function. Forever and ever and ever. What's the derivative? You said what? Cosine of x. But what if I changed it and wrote this? What's the derivative? Yep, cosine of 2x times 2. Because you had to do the derivative of the cream. You with me? This is the same thing as u. It's when the variable does not have a coefficient of just positive 1. It's whenever it's other stuff that is chain ruled out. Do we understand?
Can we go back to the triangle?
Yeah, from the triangle. What about the triangle?
How do you decide this or determine the sides again?
Okay, so I determined that this is x and 1 because I had sine, which is opposite over hypotenuse.
Okay.
And from there you just build the triangle.
Okay.
No worries. We overthink that and overlook that, and we make that difficult sometimes, and I know exactly what you're doing, and I know exactly what you're experiencing because I experience it too. Okay? So let's do a couple so that you'll see it's a lot easier than what you're thinking. The derivative rule for arctangent, okay, is this. First of all, let's build the triangle, and we know it's x over 1. So opposite, because it's TOA, is x over 1. What's the missing side? Hypotenuse, which is the square root of 1 plus x squared. Questions? If not, you've got to ask me as we go through it, okay? Okay. What does y represent again? Theta. So if you want to put y here, go for it. Same thing. What am I going to do to both sides? Take the tangent. So the tangent of y is equal to x, because the arctangent and the tangent cancel. Okay? What do I do next? Implicit differentiation. What's the derivative of the left side? Secant squared of y dy dx. What's the derivative of the right? 1. Our goal is to get the derivative by itself. So I need to divide by secant squared of y, and that's how I'll get the derivative. Okay, so here we go. Secant squared of y should be interpreted like this, and also put into your calculator like this. But by hand, I want you to write it where the 2 is in between the c and the y. Okay? If I were to look at the triangle right now, I know that secant is the flip of cosine. What does that mean? It means, yeah, but from the picture, that means it's going to be not adjacent over hypotenuse. It'll be hypotenuse over the adjacent. You with me? Okay, so that is going to go right here. So that over, so it's going to be the hypotenuse over the adjacent. And what are we going to do to that? Square. So what happens algebraically is that it simplifies it just to be 1 plus x squared. There's your rule. So arctangent, by default with u being composite functions, is going to be 1 over 1 plus u squared times the derivative of that crane. And you'll see when we start doing example problems. All these letters, they're a little confusing until you start putting numbers in there. We good? Alright. So I'm not going to work out one more because the goal is I don't want you doing all this work. I want you to memorize 9 more things. You're going to do 9 more things today. 6 are right here. And I'm going to help you memorize them because they're easy. They're really easy to memorize, okay? Don't look at this like trying to memorize one piece at a time. Find the correlations that you've used with other memorization strategies. For instance, notice that the derivatives of all of these cos are what? Negative. There's one of them already. The other one is this. The sine and the cosine are exactly the same. Again, the only difference is the negative because co is negative. You with me? And then the tangent and the cotangent, they're exactly the same. They have no square root, and I'm adding. I'm not subtracting, I'm adding. Okay? And then last but not least, these secant and cosecant ones, the big difference that I want you to gravitate first and foremost to is the fact that it's not 1 minus. It's the u minus 1. Okay? And you have also those right there. And a good way to remember that these will always be an absolute value, guys, is because the derivative, like arc secant, can you go to the computer real quick, please? Arc secant and arc cosecant, we're going to look at those graphs real quick. So let's do arc secant and arc cosecant. Okay, what do you notice about both of these? Well, what do you notice about the blue graph, the first one, arc secant? What do you notice about it? It's always increasing. Can you see it? It's always increasing. So if it's always increasing, that means its derivative is what? Positive. Look at the green one. Arc cosecant is always what? Decreasing. That's why over here its derivative is always what? Negative. Negative versus positive. Okay? But more so what I wanted you to do is I want you to look at what I was just showing you, that you want that to be the positive representation. Okay? And a good way to remember is that the derivative is doing that per se. Okay? How is it seen, if you will? Alright. So, arc sine of 2x looks like this. And if you haven't noticed it by now, this is totally not even related at all to particular solutions and slope fields. This has nothing to do with that. This is totally separate, okay? Just want to make sure. Some people were trying to find correlations last class, or the other class, first period, but they didn't say anything to the very end of the class. Okay, so what is u? 2x. Okay. So if I'm looking at arc sine, is it positive or negative? Positive, because it's not a code. And is it u squared minus 1 or 1 minus u squared? For sine. It's going to be 1 minus u squared. So it's going to be, here we go. Arc sine is going to be this one right here, where it's going to be 1 over 1 minus, and this is in the square root, and it's going to be 2x squared times what? 2. Because you got to multiply by the derivative of the crane. Will you see this like this on your paper? No, what you'll see is 2 over 1 minus 4x squared. That looks like that. Notice the 2x that I put in parentheses has now been simplified. The 2 was squared, and so was the x. Easy enough, right?
Would that be wrong in the AP?
Would this be wrong? It would not, but you're going to struggle with integrals if you don't learn how to simplify. Because the integrals you unsimplify first to find u and a, and we'll get to that here in just a bit. Okay. Arctangent. I know it's going to be positive, and I know the rule is not going to be square rooted in the denominator, and I also know it's not going to be subtracting. It's going to be addition. So it'll be 1 over 1 plus the stuff squared times the derivative of the cream. Well, the stuff is 3x times 3 will give me this when I simplify. It's pretty basic, right? It's more memorization than it is steps and processes and stuff. Okay? Here we go. Let's look at arc secant. I'm taking the derivative to get to arc secant of arc secant. Okay? Secant is the one that I'm looking at. So it's not cosecant, so it's not negative. But it will be a positive, so 1 over the absolute value. And this is where it's not 1 minus u squared. It's u squared is first. And the way I can remember that is SE, that almost looks like SEE, right? I see you. I don't know. Just something for you to remember, okay? As awkward as it needs to be. So, if I see you, there's your absolute value sign. So, I don't know, whatever you want to use. That's going to be the u squared minus the 1. So, the u squared minus the 1, now we just got to figure out what's u. U is e to the 2x. But again, you won't have it written like that on your paper. You'll have to simplify this. And what is e to the 2x all squared simplified to? E to the 4x, because power is raised to a power you multiply. Don't forget algebra 2. So you get 1 over e to the 2x, e to the 4x minus 1 square rooted. Do I need parentheses right now? Or can I put, do I need absolute value signs? Or can I put parentheses? Where this is right here. I have to put absolute value. Why? Because there's a variable left. It feels like that natural log of the absolute value of x stuff. Still a variable, put in absolute value. Alright.
The derivative of the cream.
Oh, my bad. We got to multiply by the derivative of the cream. Nice catch. So, off to the side, we have e to the 2x. What is the derivative of that? 2 times e to the 2x. It's the carbon copy times the natural log of the base times the derivative of the power. So it would be 2e to the 2x. That's it. Nice. Yeah, you have a rough life. All right, here we go. Cosine of arc sine of 3x. 2 ways you could do it. One's a lot easier than the other. Let's see which one y'all pick. How do y'all want to do it? How should we do it? Rewrite it as what? So you're saying, he's saying rewrite it, I think he's saying, by using the reference triangle. Okay. So it's sine, which is opposite over hypotenuse. There is a 1 there. So this would be opposite over hypotenuse, which would be 1 minus 9x squared square rooted. You with me? C squared minus b squared. Take the square root and simplify. Okay? Now, all of this represents what again? The angle. So if I take the cosine from the angle, that means it's the adjacent over the hypotenuse, what I really have, it's all about that rewrite, is adjacent over 1. I haven't derived a thing, I just rewrote it. Okay? That's what Krishna was suggesting that we do. Now, let's derive. So f of x, it's all about that rewrite. Chain rule says that f prime of x is what? You tell me. 1/2 times the stuff to the negative 1/2 times derivative of the inside, which is what? Negative 18x. Okay? Negative 18x. So, this means it's going to be negative 18x in the top, 2 times 1 minus 9x squared in the bottom, raised to the square root. And most likely you'd see it simplified as a negative 9x over the square root of 1 minus 9x squared. Yeah, the square root could be allowed in the denominator like that. I won't count off of that. Just negative powers I will. That was a hard way to do it. Okay? Because that's look at all that work. It's all good. I mean, hey, you do you. Let's do it the easier way that a lot of people would cringe at. But it's actually easier. Watch. Just derive it right from the start. Okay? If I derive this right from the start, that means the chain rule is going to be, what's the derivative of cosine? That's the outer shell. Negative sine of the stuff right? Times the derivative of the stuff. What's the derivative of arc sine of 3x? Well, I know the rule is 1 over the square root of 1 minus the stuff squared times du dx. That means this 3x is going to go right here. And I'm going to multiply it with a 3. Or not with a 3. Yeah, with a 3 right there. So all this right here, this work, becomes the following. And this is easier when you memorize it. Right now it doesn't feel like it's easier because you haven't memorized it yet. But it would be 1 over 1 minus 3x squared, take the square root, times 3. And then you're going to multiply, because those two cancel, you're going to multiply that with a negative 3x. So negative 3x times this 3 gives you that negative 9x. And then you still have this in the denominator simplified. You get that. To me, a lot less work, a lot less room for error, but you got to memorize the rule of differentiation for arc sine first. The negative 3x right here. So all I did was I took the derivative of the outer shell. So the derivative of cosine is negative sine of the stuff. I know these signs are going to cancel, so I'm left with negative 3x. The 9x, this u was 3x.
Well, on the numerator.
So this is the negative. See how Cameron and I were just talking about the negative 3x?
Yeah.
When I'm multiplied by the derivative of the cream, this 3 makes it a negative 9x. Because you multiply negative times 3x times 3, we get negative 9x.
Where did the rest of it go?
This, sorry, let me do a different color. This negative, numerator. This 3x, numerator. This 3, numerator. To give me negative 9x. And the only denominator left is right there.
What if you wrote the derivative together, like the one you took?
Okay.
With the sign,
They cancel. You've already done the rule. You've already done the derivative. Okay. Let's do an example for practice. We're going to do this together. Okay? Now, if you have questions, please ask me as we go. You're not going to mess up my train of thought. I will get back on. We'll be fine. But you need to ask me right whenever you... Otherwise, it's harder to explain it if you don't ask me right whenever you're not understanding. So, if you prefer this notation, you can write it if you want. Okay, there's your position function. And you want the equation of the tangent line. That means you want that. So you need two things. You need a slope. Otherwise, f prime of x at negative root 2 over 2. So you need this. And you also need a point. Okay, you need an xy point. That means I'm going to get my at value. I'm going to put my at value in the position function right here so that I can find what is my y value. There's the color coordinating. Okay, so far the point is negative root 2 over 2 is my at value. Now I just have to find what is that y value that this position function is going to spit out. So let's figure what f of negative root 2 over 2 is, position function wise. So it's 1/2 times the arc cosine of negative root 2 over 2. We learned it today. We reviewed it today. You learned it last year. The arc cosine is negative. Look at that. A negative means I'm talking about the second and the third quadrant, because that's when x is negative, to the left of the y-axis. What is the range for arc cosine? 0 to pi. So the overlap of those two is talking about the second quadrant. So what angle in the second quadrant will yield an x value of negative root 2 over 2? 3 pi over 4. So 3 pi over 4 times this 1/2, do you agree? Is going to give me what? 3 pi over 8. Now I have my point. I need to get my slope. I don't have my slope yet. Okay? Alright, so let's get our slope. We're going to derive this. We're going to get f prime of x. Okay? Constant multiple rule, that 1/2. Just put 1/2 to the side. What is the derivative of arc cosine of x? You learned it today. The negative 1 over the square root of 1 minus u squared, right? Which is x squared times 1. So here's my equation. And if you want to simplify it to this, that's okay. Because what are you going to be plugging into your derivative function? Your at value. So you're going to plug in this negative root 2 over 2 right here. And there's a lot of algebra that's going to happen right now that I need you to follow closely, because I don't want to re-explain it, okay? This negative root 2 over 2 is about to be plugged in right here where x is at. This is a problem that you would not have a calculator with. Now I'm teaching it to you, but this you could do in 2 minutes, okay? If I plug in negative root 2 over 2 over here, and I square it, what do you have? You have 2 over what? 2 over 4. So, which is 1/2. Everyone needs to hear that. I'm not going to write 2 over 4. I'm going to write 1/2. How did I do that? I put the negative root 2 over 2 where the x is at, and I squared it and reduced. Okay. This is f prime. Now, what is 1 minus 1/2? 1/2. So what I'm doing here is I'm taking the square root of just 1/2. the square root of 1/2 is the same as square root of 1 over root 2. So this square root of 1/2 is the same as if I were to rewrite this square root as this, 1 over root 2.
Would you not have to take the root and put it in the numerator?
Okay, yeah, we're almost there. We're not there quite yet. But right now, let's say I've multiplied now the denominator. What would you get? You get 2 over root 2. Okay? And if you get 2 over root 2 here, think about this. This is the same as -1 divided by 2 over root 2. Otherwise, what we've said all year, keep, change, flip. So the derivative, and I should have been putting, right here, for all these x's, I should have been putting negative root 2 over 2 because we're actually evaluating it there. So f prime at negative root 2 over 2 actually becomes negative root 2 over 2. Just by coincidence. There's no correlation. It's some crazy coincidence that it ended up being the same as the input. So the slope is negative root 2 over 2. And now, I could just write it as far as y minus y1, which is 3 pi over 8, is equal to this negative root 2 over 2 slope that we got of x minus our input value right here. And this was our y value. And this was our slope. Done. And yeah, you'd probably simplify this to x plus. You don't have to. If it was multiple choice, you just find which one it was equivalent.
Will this video be on classroom?
Yep.
Oh, sweet.
So, here we go. Let's now go to, we have one more page of notes and then we're done for today. Okay. The integrals. 3 more things to memorize, not 6, but just 3. And the reason of it is, someone asked me, why are there just 3, but there was 6 of the other ones? Because look at this. This is like a squared minus u squared, which is the same as the 1 minus u squared. The only difference is one of them is a what? Negative, and the other one's a positive. So constant multiple rule helps here because this arc sine can be the same. The only difference is one is a negative and one is a positive. Go with me? Okay, here we go. It's all about identifying what's A and what's U. Okay? What letters, and I think it was in this class, did we say were constants? A through what? I guess it wasn't in this class. Because someone said in the other class, A through K, because of the last day of notes that we did. Remember K was a constant of proportionality, with directly proportional, inversely proportional. So if you want to add that, that's good. Or just A through E, and then just remembering the K. All right, here we go. So, it's all about identifying the A and identifying the U. Which one is a constant, A or U? A. Okay, so here we go. A and U. Quickly, guys. So what's A? From looking at this, what is A? 2. And what is U? X. So all you have to do is when you see it in this form, is you're going to, these are things of memorization, this A minus X is right here, and you're just going to put is equal to the arc sine, you could write it either way, of U over A. So X over 2 plus C. Done. Okay? Let's do the other one, the next one. What does that look like? There's no square root, so we know it's not sine or cosine, or secant or cosecant. It could be tangent or cotangent. What do you think it is, cotangent or tangent? Tangent, because it's missing a what? A negative. So this is going to be tangent, and again, that's why you only have one, because you can constant multiple rule that negative out if it was there. And it would be the negative arctangent. The negative arctangent is the same as arc cotangent. Go with me? Did you hear what I just said? Because some of you are dozing off. You good? Okay. So what's A? 3. What is U? X. So my integral from rule of integration here, and this again, this is the annoying part of Calc 2. So I've taken Calc 1 to Calc 4. So Calc 1, Calc 2, Calc 3 is multivariable, where you're deriving in more than just one variable. It's not like d over dx. You're deriving into multiple variables at the same time. Okay, which is cool. But and then Calc 4 is differential equations. Out of all 4 of those, I'll tell you right now, whether you're a math major or not, most people who are not math majors, they would never survive a Calc 2 class. They wouldn't. And people who are math majors, that's the one that prevents them from going on to their engineering classes if they don't do well with Calc 2. And why don't they do well with Calc 2? Doesn't it feel like it's stupid and boring to memorize senseless stuff? This feels like senseless stuff. And there's probably 30 to 40 different equations that you have to memorize like that in Calc 2 that associate with this. With that being said, you don't have to do 30 or 40, you have just 3. So you should be able to memorize 3. Okay? So, let's look at this, and we're going to go 1 over A is multiplied with the arctangent, and again, you can write it like this if you want, of U over A plus C. And why is this wrong? Find what's wrong with it. There's balance. So this is not indefinite. This is definite. And instead of writing the parentheses here, I only want to work with this 1/3 one time. So I'm going to constant multiple rule it out, and that's what I'm going to look for. So let's concentrate right now on doing this part right here. Okay, here we go. And if you get confused, please stop me. This is another one of those, you gotta let me know immediately. So let's plug in this 3. And what we're looking at is the arctangent of 1. I know you've memorized a lot. I know you've covered a lot this year. But the shortcut I gave you with that was to envision a positive 1 slope at the 45s. Can someone tell me what the arctangent of 1 is from the information you learned today? Pi over 4. Because the range of arctangent is from negative pi over 2 to pi over 2. So not both of them, just pi over 4. Okay? Minus, now let's plug in this root 3, whoops, the root 3 over 3, so that you get, okay, root 3 over 3. You have 2 choices. If you pick incorrectly, well then it's your other angle. It's either going to be pi over 6 or pi over 3. Which one do you want to guess? Pi over 6. So let's do pi over 6. Pi over 6 is 3, 2, 1, 3, 2, 1. So it is a root 3 over 2, positive and positive. The tangent is the y over the x. And I just wrote that out to save a little bit of time and do keep, change, flip. Does this simplify to root 3 over 3? Yeah. So this would become pi over 6. And last but not least, you constant multiple this 1/3. Okay, here we go. Pi over 4 minus pi over 6 is the same as 3 pi over 12 minus 2 pi over 12 with a common denominator. So you get 1 pi over 12 Right? Do y'all see it? That if you multiply with 1/3, you get what? Pi over 36. Should I put units squared? No, because it's not area. Even though it represents area, it's not an area bounded problem. So don't put units squared. Should I put, like, if this represented miles per hour, I would have to put miles right here, right? But that's not the context. It's just the numeric value. Just put that. Some of you on the last test, you're putting units squared on all of these, and you don't need them on all of them. Okay. Almost done. Almost done. So we have x, square root of x minus 25. You see that it's the variable minus the constant. Otherwise, the variable minus the constant. Go with me? So what's a? 5u is x. So here, it's going to be the 1/5 arcsecant of the absolute value of u. And again, because secant is a positive, because it was increasing the entire time, you want that absolute value of u, which is x, over a, which is 5, plus c. That's it. A lot of plug and chug memorization type of stuff. That's it. Okay? Now, we're going to have more practice next class, but this is a prelude to next class. Is when do you know to use these new things that you just learned? Because it'll be on the AP exam. What's your first go-to when you do integration? I want to pick your brain right now. What is your first go-to when you first look at an integral? What do you gravitate to first? What you can take out. Constant multiple rule. Perfect. What's the next thing that you gravitate to? If you can split it up, yeah, if they're adding, do multiple ones. But if it's all multiplied together, it's going to either be a rewrite or it's going to be use substitution. You with me? And now we've added even more to that, because don't do use substitution on everything. Sometimes you need it, sometimes you don't. And these 3 case scenarios right here will tell you when and where you need it. Do you need it on the first one? Do you need use substitution? No. If you did use substitution, what would you put as u? X squared plus 9. But I'm not going to do that, because if I take the derivative of x squared plus 9, I get 2x. I don't see a 2x anywhere to pick up the scraps. So, constant multiple rule. 1/x squared plus 9. You learned it today. Which of the inverse trigonometric functions do you see right now? Tangent. You see arctangent, right? And arctangent is 1/what? 1/a? Remember? Oh, you don't have it pulled up. My bad. I have it down. So it's 1/a. What's a in this one? 3. And if you need to write it here, what's u? X. So it's 1/3, the arctangent of what? Not the absolute value, but u/a. U is x, a is 3, and then plus c. Now we are multiplying this by what? 4, constant multiple rule. And no, you don't have to put 4/3 and 4c, just c becomes bigger. So we could put it like that. Not too bad, right? It's just a lot of algebraic manipulation. Can we do what we just did on this one? No. Why? Because the variable, you still have an x in the numerator. Watch this, because it's bringing everything together integration-wise. Whoops, what am I doing? So it's not this. It's not arctangent because of the variable. What do you suggest? Use substitution. What's du? 2x dx. So what is the rewrite? Careful, because it's been a while since we've done this. I'm going to do the rewrite only for this part right here. Don't look at the 4. just do the rewrite based off what you found over here. What's the rewrite? 1 over u du, and then the 1/2 comes out because of that. Then the 4 is out here. The 4 times 1/2 simplifies to 2, 1 over u du. And can someone tell me what's the integral of 1 over u? Yeah, natural log of the absolute value of u. Plug it back in. Multiply this constant multiple rule of 2 and plus c. Totally different, right? Not even arctangent at all. Okay, one more and then we're done for today. What is my go-to here? Is it arctangent? It's not, because I have a variable in the numerator. I want to know what you're thinking. What do I do? I mean, I can pull out the 4. Okay? And then where do you go from there? You can do u sub. U is what? X squared plus 9. So that du is 2x dx. So again, we're only going to concentrate on this right now with this right here. Do you see how it's going to be 1/2? So the rewrite is 1/2 of 1 over u du. But what else is there that we haven't yet picked up? What haven't we picked up yet? We haven't picked up one of these x's. It's like the top is x times x. We picked up one of them. Whoops. We picked up one of them right here and here, but we didn't pick up the other one. So remember that annoying extension that we had to do with this u substitution by also solving for x? I know, that's a lot, right? So you still have an x where it's going to be the square root of u minus 9.
Can you just substitute that square? No, wait, actually, I'm still forget that.
The 4's still there, right?
The 4 is still here, out here in the very outside. We still have this going on.
Just split the fraction.
We can't split the fraction because you can't do that inside of a square root.
Bring
This
the
is,
u up.
huh?
Bring the u up to the u to negative 1. We'll find it.
Again, you wouldn't want to bring that up because it's not a constant. Don't give up. We'll finish this next time. Go to lunch.